Hello everybody, my name is Winola from 10 Science Tools Mak Tunas Bangsa Gading Serpong. So in this video, I will teach you a simulation of molarity using the PhET simulation. So actually, for me, when I heard the word molarity, I will directly remember the formula of concentration equals to moles divided by volume. So this is the reason why when we want to use the simulation of molarity, we could find solid amount in moles, solution volume in liters, and solution concentration in molarity. So actually it's almost the same. In the simulation, we will try to find the relationship between moles, liters to the molarity. Okay, now let's start the simulation. First, I will teach you actually how to use the simulation. So first, you can see that there is solute here. When we press it, there is a lot of solute. You could choose one of them, or you want to choose many of them. It's up to you. But here, I will try to use the drink mix first. And if you want to know the solution values, you can press the button here. And now we could see how many moles, how many liters, and how many molarity. And to make a difference, you could pull this up, push this down, pull this up, and push this down. Okay, now let's really start the simulation. So here, when I start using the drink mix, we start from 0 moles, 0.2 liters, just an H2O, and 0 molarity. First, I will try to increase the moles first, the solid amount, and see what will happen, okay? Okay, so when I try to increase the solid amount in moles, we could see together that the molarity is increasing also. So finally, when the moles reach its highest maximum, we can see that the molarity also reached its maximum, 5. And look at the beaker, now it's not an H2O, but already a drink mix with the red color. But what will happen next if I try to increase also the solution volume in liters? So let's see. Okay, as we can observe here, when I try to increase the volume, the molarity is decreasing. So finally, when the liters is at the highest maximum, we can see that the molarity now it's only 1. And look at the color of the solution. Now it's more transparent than before. So the last thing, when I try to decrease again the moles, what will happen? So let's see together. Okay, we could see that when I try to decrease the solid amount in moles, the molarity is also decreasing. Decreasing until finally when the moles reach 0, we can see that the molarity is also 0, and the solution inside the beaker, now it's just an H2O and a transparent color. So actually, what conclusion we could get here? So I know it's very simple. So the lower the solute amount and the higher the solution volume will form low molarity. But the higher the solute amount in moles and the lower solution volume in liters will form high molarity. Okay, that's for drink mix. Next, I will try using copper sulfate. Okay, so copper sulfate, we start from 0 moles, 0.2 liter, it's still an H2O, and here, this is the difference between the drink mix. We could see that the molarity of copper sulfate is only until here, maybe 1/4 of 5. But drink mix, we could see that it reached the highest maximum. But copper sulfate only maybe 1/4 of 5. So what makes it different? So let us see together, okay? Okay, like the solution before, I will try to increase the solid amount first. Okay, the same like drink mix, when I try to increase the solid amount, the molarity is also increasing. But what makes it different is this. When the moles is at 280, we could see that the molarity already reached its highest maximum, 1.4 molarity. So what will happen next if I try to increase again the moles? So let's see. Okay, so when I try to increase the moles, we could see that the molarity didn't increase again, or didn't decreasing. But what's changing is, look at the solution. There are crystal forming and it's increasing till finally when the moles is at the highest maximum, the crystal becomes more many. So actually, how could this happen? So it's actually happening because this solution in which the maximum amount of solvent has been dissolved. So because the solvent has been dissolved, already reached its highest molarity, so crystal will form at the bottom of the beaker. So that's why it's named saturated, because the solute is saturated. Okay, so now what will happen if I try to increase the solution volume in liters? Let us see. Okay, when I try to increase the volume, we can see that the molarity hasn't changed, hasn't decreased or increasing. Different like the drink mix, when I try to increase the solution volume, the molarity will decreasing. But for copper sulfate, when I try to increase the solution volume in liters, we could see that the molarity is not changing, but the crystal is decreasing. The crystal is decreasing until finally when the crystal is all gone, we know now that the molarity is decreasing. Until finally when the volume is at the highest maximum, the molarity is only 1. Now I will try to decrease again the solid amount into 0. Okay, we could see that this is actually the same with drink mix. When I try to decrease the solid amount in moles, the molarity is also decreasing. Till finally when it reaches 0 mole, it's just an H2O and the molarity is only 0. So actually, the conclusion for copper sulfate is almost the same with drink mix. The lower the solid amount in moles and the higher the solution volume in liters will form low molarity. But the higher the solid amount in moles and the lower the solution volume in liters will form higher molarity, but the difference is there will be a crystal formed because the solution is saturated. So I think that's just the difference between copper sulfate and the drink mix. For copper sulfate, there is a crystal form. For drink mix, there is no crystal will form because it is not saturated. So that's it for my simulation using PhET simulation of molarity. I hope you understand this simulation and you can use this simulation or try this simulation using the link here. I will put it in the chat box down there, and yeah, I hope it can help you using this PhET simulation. So bye bye.